This is part two of the economic geography lecture. This is a slide I added after I started talking about the four stages in the formation of coal. Coal starts out basically as gigantic masses of decaying vegetation that accumulates over time. Then it gets compressed either geologically as sediments accumulate over it or as the land masses get caught with um, continental drift or tectonic plates and all that, and land gets crumbled and pushed together. It compresses that coal, and it can turn from what we originally called peat or peat moss. And in fact, you see here a slide of folks harvesting um, peat in Ireland. There's a couple of guys with shovels and picks and wheelbarrows. It can be burned. It's very smoky. It's not a good quality fuel. Over time, that compresses and it becomes brown coal, which is used in many parts of the world. For example, in Poland, they run electric generation plants off of it. It's really not quite really a rock yet, because in fact, if you ship brown coal large distances, it starts to crumble and turns back to peat basically. So you can't move it very far. But the better quality coal is then called bituminous, which is close to the surface, often strip mined. Um, but one of the best quality coals that they had in western Pennsylvania when Pittsburgh started as the center of the American iron and steel industry is anthracite coal. It's better quality because it's been compressed, but that means it's been pushed and it's located farther down in the earth. So that's the type of coal you have to go after with deep coal mines and people working underground with machinery and so on, rather than just strip mining it off the surface. Um, a good part of what we're talking about today is geography is about where things are. An important factor is shipping things back and forth and what it costs to manufacture it somewhere and ship it somewhere else. So an important factor in this is if you think of the cost of shipping something, you think about this yourself, because if you buy something on eBay, somebody says, well, I have this coffee mug, I think I can sell it on $3 for eBay. But if it's going to cost you $5 to mail it to somebody, nobody's going to buy that coffee mug for $8 now. So the proportion of the shipping cost as a proportion of the value of an item is important, particularly when you're talking about, manufacturing, a million flower pots or something. Where are you going to ship them to, and how much is it going to cost you to ship them there? So if you have something like $1,000 watch made in Switzerland, the proportion of the cost of shipping that is essentially trivial, because you could mail it out by FedEx or something and you wouldn't really care that it cost you $20 to send it to somebody, or $18 to send it to somebody, because the item is so small and so valuable that the cost of shipping is relatively insignificant. On the other hand, if you're in business and you're manufacturing concrete blocks, I happen to think of this because I happened to see them at Lowe's the other day, and I was amazed that you can buy a concrete block. I think they were $1.01. Well, that's great, but you can't ship those very far. So what you would find is that concrete blocks are made all over the United States locally, because it doesn't pay you. If you're going to ship 10 of those, it might cost you $10 to ship them somewhere. I have a comment, another example of a kind of a wasteful example is bottled water. We might say, well, I drink this bottled water from a glacial stream in Montana or something. And, there's not really a lot of difference in these things. But the point of that is we're in a country where we're wealthy enough to pay for bottled water to be shipped, let's say, from Montana to Ohio, so we can put it in our vending machines or wherever it comes from. um, because the cost of shipping and the cost of the plastic container is probably more than the actual cost of the water. But um, it doesn't matter all that much. We're willing to pay $1.25, put our coins in the machine or whatever to get that bottled water. And on a larger scale, we'll probably mention a couple of times, and you've seen a video about this where the woman works in the maquiladora. The maquiladoras are the manufacturing plants that are right across the border in Mexico, right across the border from the United States. It's a Spanish word. It comes from the word to mean to assemble, because they're putting things together. And even that, because you could ask, well, why do we still manufacture things in Mexico? Because, like, actually the Mexican economy has become much more like the United States is over time. And Mexican manufacturing workers are probably getting twice as much as manufacturing workers in China. So why are we still making anything there at all, even in Mexico? And a lot of times it's because they're larger, bulkier goods. So a lot of appliances are made in Mexico, because now if you're shipping a washing machine or a clothes dryer or whatever, that's a large item. And while we do import some of those things from China and other countries, you save a lot on the shipping cost by just loading it on a truck and sending it across the border. And literally, distance also comes in the fact that they are just located across the border. Literally, if you're shipping 50,000 washing machines a year, the fact that you're located in Ciudad Juarez, just across the border from El Paso, or you're located in Matamoros, just across the border from Brownsville, Texas, or wherever, the fact that you're only 10 miles away from the United States is significant. When you multiply that by shipping 50,000 dishwashers, compared to, let's say, locating in central Mexico and then having to move them an additional 1,000 miles, perhaps. And literally every day, every time that energy costs go up or down, that affects shipping distance and where manufacturing locates. If tomorrow the price of oil doubled, we'd bring back a lot more manufacturing to the United States, because all of a sudden all these things are being shipped all the way from China and from Europe or from India or wherever they're coming from. It would be a little more economical to make them in the U.S. again. On the other hand, if the price of energy keeps going down, particularly the price of oil, then that means, well, it's now more economical to maybe make something in Africa or South America and ship it to the United States. So it's very geographical. Here's a map showing the location of a lot of the cities along the U.S.-Mexico border that have a large number of these maquiladoras. And again, I just show it to point out how many of these manufacturing towns are literally along the border, although they're not all there. I mean, there are other clusters of manufacturing plants that supply the United States market all throughout Mexico, but most of them are literally right along the border. Here are some other examples of how distance in shipping, and sometimes it's not just the cost of distance, but freshness enters into it too. Remember, we discussed in preserving things, we discussed this in the context of the Upper and Lower South. You couldn't ship fresh milk in those days from West Virginia to Baltimore or something. It would spoil before it got there. And in the old days, before cost improvements and decline in shipping costs. So there's two things here. First of all, you have to have the roads. So the interstate highway system that was started in the 1950s was actually started as a defense measure so to speak. The president then was Eisenhower, who had been, he was elected in large part because he was the leading general who coordinated the end of World War II. He was the commanding army general and so on. And so he was very popular. He was elected president. And he had the idea, we really need a system of national highways. Suppose somebody attacked us, Russia or somebody. How would we move troops from, California to New York or whatever? That was how the interstate highway system started. As a secondary impact, it affected a lot of location in the United States, both location of residences and location of industries, particularly when we started building beltways. And to some extent, these new highways led to the suburban malls, which led to the decline of downtowns and really the whole era of the suburbs and so on. Because while suburbs had started earlier, we even had streetcar suburbs back in the days when they were trolley cars. But suburbanization exploded for both residences where people lived as well as for industries. So an example, I gave an example here of two beer brewery maps. Up through even the early 1900s, every city or town had its local brewery where certain beers were made. Because in this case, it wasn't necessarily freshness, but it was just the idea that you couldn't, manufacture beer in Columbus, Ohio, and ship it to New York. It was just too costly. With declines in cost, shipping costs, and improvements in transportation, bigger trucks, better roads, it then became possible, and pretty much you see a lot of the breweries in the same pattern. The red map, which is a little hard to see, I realize, are Budweiser breweries where they make the beer and then distribute them. In fact, there's one, as you can see as you travel along the northern beltway in Columbus, I-270, you can see the Budweiser distributor, the Budweiser factory there, basically, which is a different thing from the warehouses you see around. Like you see a warehouse as you leave Zanesville and head toward Newark. There's a Budweiser warehouse. They don't actually manufacture it there. The one on the right is it Coors Miller? I think Coors and Miller combined now, and you see some of their locations around the country. Bakeries are similar. Not talking about little bakeries where you buy cupcakes and birthday cakes, and talking about big bakeries that make, Sunbeam bread and Wonder Bread and things like that. They have similar locational characteristics like the breweries. They may have 8 or 10 or a dozen plants around the United States. Even newspapers, if you think of it, is kind of a local manufactured product because you have to be close enough to the extent that people still read newspapers, and some do. Older folks, oftentimes the market for younger people for news has gone to the web, of course, but you have to be close because you're printing that paper today and people expect it in their, mailbox tomorrow morning or whatever, or in the little newspaper stands where you can buy them outside of office buildings and so forth. So these are all different examples of manufacturing that are still around. And to some extent, the extent to which you have, if we look at the Budweiser map again, you could say, well, wait a minute, why don't they just have one gigantic plant in St. Louis where their headquarters is? St. Louis, yeah, that's right. And ship it all over the country. And the answer is, it's not quite as efficient as having these decentralized breweries. It makes more sense to have, let's say, a dozen of them and have each one, this will supply the Southern California market, that'll supply the New England market, and so forth. So it's really almost a mathematical equation about how many manufacturing plants you have, where you locate them, and it's based on shipping, decentralizing those shipping costs. In with beer and bakeries, resources, as we saw with iron and steel. I mean, it's not like you can get water anywhere, you can get flour anywhere. Uh, it's not like shipping tons and tons of iron ore. So it's not as the shipping of the raw materials is not as much of a factor as the cost of shipping the finished item to the market, which brings us back to that previous slide about um, the watches versus the concrete block. In that case, the importance is what's the cost of shipping it to the market. So we've seen textiles, it was what's the cost of labor. With iron and steel, it was what's the cost of shipping raw materials. With consumer products like beer, bread, newspapers, many other things, the cost is what's the cost of shipping it to the consumer, to the market. And there's all kinds of interesting things you can look at here. In fact, when you trace back, they call these commodity chains. This one is an example for a laptop computer. It's, there's a great deal of complexity in your computer, and parts for it are produced all over the world. So when you kind of map out where all these different pieces come from, where's it put together, and so on, they call it a commodity or a supply chain sometimes. And so you see, for example, the copper that's in the wires and components probably coming from northern Chile because that's the biggest copper producing area in the world, whereas your lithium, which is a mineral that goes into the battery, comes from a close by area, probably like Peru. The aluminum that's in it is probably coming from a bauxite ore that was shipped from Australia to Japan for assembly. Different pieces are assembled in different places, so you make the hard drive, and then the hard drive is shipped to another place to be assembled, and so on. A lot of this assembly occurs in, of course, China and increasingly in Southeast Asia. In fact, the what was it? I think it was the transistors are now so specialized that when this area was hit by I think it was a typhoon a while ago, and they had flooding in Southeast Asia, and it shut down some of these plants for a couple of weeks. It affected the industry worldwide. Such a large proportion of these, and it may have been, wasn't the manufacture of the chips, but it was the assembling of the chips. It delayed Apple. Apple had a new laptop coming out or whatever, and it delayed them for a couple of weeks because so much of that manufacturing is specialized in a small area that got hit by, I believe it was flooding from a typhoon. And where are the wafers made? Well, the United States still makes some of those, some in Europe and some in Japan. But how you bring all this stuff together is called the commodity or supply chain. Another important thing about economic geography is that specialized clusters develop in both manufacturing and the tertiary industries. So this is another aspect of it. It's not all entirely about shipping costs and so on. It very often happens that different industries cluster in different areas. In a sense, the initial rise of Pittsburgh as an iron and steel center was a clustering. It wasn't just one steel mill, it was dozens of them that developed. And sometimes it happens because of raw materials, as happened with Pittsburgh and the iron ore and the coal and so on. But sometimes it can be an innovation or an idea. And an example is in upstate New York, Rochester, for whatever reason it gets started, not just Rochester, but neighboring cities, they get into optics and imaging It started with, in part, with the film industry in the days when we had literally film in your camera instead of digital imagery. And probably many of you are old enough to remember, Instamatic cameras and things. You had to buy film for them before everything got taken over by digital, or the Polaroid cameras that took the instant pictures. Manufacturing film was a huge operation. A lot of it was in upstate New York, and a lot of times you get different firms starting simply because once it starts somewhere, it could be something as simple as this. So you have this big plant, Kodak or whatever, making a lot of money in upstate New York, and people working there, and one of the vice presidents perhaps says, "Hey, I can do this." So he or she goes across the street and opens, Polaroid, and starts a competing business. So sometimes that happens. The second thing is you accumulate a bunch of folks who have specialized knowledge. Some of them, back in the days of film manufacturing, some of the world's most prominent specialists who knew all the little tricks about manufacturing film and running the film assembly line and all, were right there in upstate New York. So you hire those people away to work for your company. But the point is that specialized knowledge is clustered there. And then that evolved. So, people don't buy much film anymore. Well, what happened though was because of that specialization in making the little Instamatic cameras and things, they get into lenses. So there are large, like Bausch and Lomb started up there manufacturing eyeglasses and optics. And because of all this knowledge about imagery, this was the place where Xerox started making copy machines, because a lot of that had to do with lenses and optics and so forth. So that becomes a cluster of specialized knowledge like that. And you can see that, and I'll show you before we leave the map, because on the next slide I've got kind of a list of some of these. But part of the idea of this is sometimes it's related to raw materials. So if we go out to Oregon, we see that one of their specializations is, of course, woodworking and woodworking equipment and logging equipment and so forth. That has to do with raw materials because you're out on Oregon, so it makes sense that Oregon and Washington, Northern California is still kind of a center for the American lumber industry. Or another raw material example, besides, of course, Pittsburgh is still on here as a center of metals manufacturing and so forth. Another example, I don't see, there's my cursor, down in Houston, and it actually says the Texas and Louisiana coast. You remember Texas for many years was our biggest oil producing state. Well, many petrochemicals and plastics and so on are made out of petroleum as the raw material. So that area has become a specialist in petrochemicals and plastics and so forth. So those are raw material clusters. But you can also have tertiary clusters. So Hartford, Connecticut remains as one of the big insurance centers of the United States, and all the many world specialists in insurance are located there. Or New York City is another example with financial services. Wall Street has nothing to do with where raw materials are. There's a cluster of world experts in financial services, advertising, publishing, and so on. Another one is Los Angeles, of course, around Hollywood with the entertainment industry, and then that's morphed into digital, with all the animation and digital production, not just actors and people running cameras, but there's a lot more to it over time. And here's a list of, I think the next slide gives you a list of some of these. Of course, the classic one is manufacturing automobiles in Detroit. American automobile industry has been hard hit. Detroit has been hard hit with closing of a lot of factories, but there's still some there, and the auto industry, because it's a big, bulky product and requires a lot of specialization, the auto assembly industry and the auto parts industry, who makes the glass, who makes the tires, who makes the batteries, so forth, um, hasn't really left the upper Midwest. I mean, there's plants all over the United States, but there's still a very distinct concentrations. So to some extent, it didn't so much leave Michigan as it decentralized out a bit to the next layer of states around Michigan into Illinois, Indiana, Ohio. So, of course, Ohio is still a big producer of automobiles, whether it's Lordstown plant up near Youngstown and Cleveland, or the Honda plant in Marysville, about an hour away from Columbus. That specialized cluster is still there. I mentioned New York and Rochester and Houston. Said Hartford, Connecticut for insurance. Another kind of specialized cluster that developed is in Omaha, Nebraska. Of all things, they get into telemarketing, so they handle, if you call with some problem on your credit card, or you call Expedia with some problem in your hotel reservation or whatever, and if you don't get someone in India, because, we do a lot of outsourcing of that these days, now that telephone communications are instantaneous and can be worldwide. But anyway, Omaha has a lot of the American processing of those kinds of things. We talked about textiles. Georgia still remains a center for the textile industry, particularly carpets, what's left of the textile industry, and as does North Carolina. I believe I told you that while a lot of the natural fibers like cotton and linen have gone elsewhere, North Carolina still remains a producer of things like nylon and rayon, so they still make a lot of those textile products there. North Carolina also happens to have a big cluster of the furniture industry because of the hardwood trees and so on that are located there. I don't want to talk, we're talking about human geography worldwide, so I don't want to focus. I like to give examples of the U.S. because we can relate to it, but these principles apply worldwide. So I searched for a map here and found here's an example of industrial clusters in Italy. And you don't have to know any of these. I'm just showing them to you as an example, but the light blue indicates food industry products, might be olive oil or wines, for example. Italy has a lot of the fine paper industry. For example, they make very expensive little notebooks that people, when you see the word, you'll think it's moleskin. It looks like it is spelled moleskin. It's actually pronounced moleschina. They make things like that. They have a big plastics and rubber industry. They make jewelry in the orange area. They still have a lot of leather and shoes. And the red is textile and clothing. And of course, Italy is very well known for the fashion industry. And a lot of those are still, a lot of it, Italy has the same problem. When I was young, the shoe industry left, the United States lost the shoe industry, particularly New England, and most of it went to Italy. Then, and it was like, shoes are always made in Italy. Well, not so much anymore. You go to, one of these shoe warehouse places or whatever, and you'll see that most of the shoes now are made in places like China and Bangladesh and so on. But Italy still has some of that industry. But the point of this is that they are found in clusters. They're not just scattered around the country for the reasons we talked about, the specialized knowledge that accumulates, where are your resources, where are your highways, where are your trucking, what are your shipping costs, and so on. As we finish this out, and this lecture is going to be, I think, a little bit shorter than the last one, but I want to touch on some other concepts in economic geography, um, including growth poles. And I'll have a slide for that. I'll have a slide for uneven development. I just mentioned transnational corporations. I'm sure you know what that means, and it's um, any big, what we say, an American corporation these days, whether it's IBM or Ford or Xerox or whatever. They're really transnational. They have sales and increasingly manufacturing all over the world. I mentioned just now the Honda plant in Marysville, Ohio. In the old days, it was like, well, don't buy a Japanese car because that gives all the employment, and money and everything over to Japan. But now it's almost like, Toyota is a worldwide corporation. And when you buy a car that's made in, even if it's Toyota and it's made in Marysville, Ohio, that's giving employment to people in Ohio, and they're buying their, the tires from Akron or wherever they're getting this from. But this whole issue of who controls these corporations and who taxes them and so on, which just, if you follow the news at all, there was a big fuss about, what was it, Burger King bought Tim Hortons, which is a Canadian company, because it's going to give them they're going to have to pay less American taxes. So there was a big fuss in the news about that. So there's all kinds of issues to do with transnational corporations. I mentioned outsourcing, which means the term has come to mean sending stuff overseas, like call centers in India. If you run a credit card company and people call with issues, hey, I didn't charge that or whatever. It's a lot cheaper to have somebody from India answer the phone. India in particular, this ties back to the language maps, the language stuff we talked about. Places like India and Jamaica is another one where people speak English. That's a big advantage in call centers, because of course if a lot of your customers are Americans that want to speak English. I read just a little funny story about this. It was a training center for telemarketers in India, and one of the things they said to the folks is you got to pick a English sounding name. And when the story says, well, this young man said, okay, I picked my name. It's Chesterfield, which I suppose is more of a British sounding name than an American name. But I thought that was kind of cute that he would pick the name Chesterfield, thinking it was a modern kind of English sounding name. But there's a whole issue, which I put here as a question mark, does trade benefit all countries? The basic principle of trade at the very basic level is, all right, my country has coal, your country has bananas. Neither one of us has the other's product, so obviously we're going to work out a deal and trade. And kind of the second level is we could all make shirts, but it turns out because your country has a lower standard of living or whatever, or a greater population that needs work, you're going to be able to make those shirts by paying people $1 an hour, whereas my country would have to pay them $2 an hour. So we'll make a higher quality good like automobiles instead. So you send us 1 million shirts, we'll send you 50,000 automobiles. The principle is that, so now my country is getting shirts for $10 that would have cost us $20 if we had made them, in theory. But there's also this, and improvements in transportation always help and so forth. But there's always this issue, and I'll relate it back to kind of a saga of West Virginia, that some folks have explained it this way. Let's go back to the interstate highway system. Yeah, West Virginia was always a lower income, more isolated state. When the interstate highways came through and they built I-77 going north-south, and what was it, a 64 going east-west, yes, oh, now West Virginia will benefit. They'll be able to, West Virginia had a lot of sawmills at the time, kind of mom and pop sawmills. They'll be able to, um, sell lumber now, and people in West Virginia will make more money and so on. What actually happened was those sawmills went out of business because they couldn't compete with the huge Weyerhaeuser plant that was located in Baltimore that could ship in wood from all over the world and plywood and so forth. Now, you could argue that, well, but still the people in West Virginia benefited because they could get cheaper wood than they used to get. Turns out they didn't realize when they were buying lumber from the mom and pop operation, they were paying twice as much as they could get it from a national lumber mill if they could ship it in cheaply. But that is the dilemma, that this issue of does trade benefit all countries? That is the dilemma that is up for debate. And in fact, what some countries do relates to the next item on the slide, import substitution, where you want to impose trade barriers. You say, if we don't tax, it's called a tariff. A tariff is a tax on an imported good. We don't tax lumber coming into our country, they're going to put all our lumber mills out of business. So it makes a trade-off. Textile example, actually, we think the Industrial Revolution was wonderful. We invented these machines. We could produce cloth for 1/10 what it used to be back in the 1820s. Actually, the first thing that happened was we put a lot of cotton producers in India out of business, where people were making stuff by hand on looms with like needles, and 12-year-old kids making these things and so on. So there's a trade-off between getting the things more cheaply and putting your own people out of work. And in theory, if we wanted to go backwards, the United States could have said, we don't want to lose our textile industry in North Carolina. We're going to tax shirts coming in from China. Instead of letting them, be sold now for $8, we'll make them be sold for $16. It'll cost twice as much, and then people will buy the $12 shirts from North Carolina. I mean, that's a simplistic example, but it is the idea, and it's still true, that some countries still believe in taxing imports so that they can grow their local industry. And it's not at all clear about who gets the best part of the deal when you make the trade. When we go back to the coal and the bananas, who's ripping who off here. So it's a big debate among economists. Then there are, the book talks about the phrase externalities, good and bad. Usually externalities are spoken of as a negative thing. External, keep in mind what the word means. External means like outside, and it means, in a sense, to an industry, it means, not my problem. In the old days, more so than now, this is actually a picture from the slideshow on the Portuguese Americans, what the environment was like in, this looks around, 1920-ish or so. Certainly before the days of pollution controls. It simply meant you could put pollution into the air and it was somebody else's problem. So it was an externality. You could dump your waste into the river, not my problem. So that means something you don't have to take into account when you're adding up your costs of business. How much can I sell this product for? If you say, I'm not going to worry about air pollution, it's an externality. Now, if the government makes rules and says you're going to clean up that smoke, and in the smokestacks before you let it into the air. Then it does become a factor of production. The best examples are often negative ones, but positive things can be externalities. When Boeing, the big aircraft manufacturer, is located in Seattle, they have a lot of folks there who used to work, retired for Boeing. They have a lot of aerospace knowledge, avionics engineering knowledge, which they've brought to that area. And that is a positive externality, because that's an opportunity for another company to come in and say, hey, there are all these aviation engineering experts in the Seattle area. So when I start my, I'll make small airplanes or something, I'm going to go to Seattle. That's a positive externality. The rest of the things on that list, I believe we will talk about. We have slides on those. So one of them was growth poles. Think of it this way: given that industries develop in clusters, whether they're manufacturing industries or they are high-tech industries, and probably one of the best clusters I didn't even mention, but we hear Silicon Valley. Silicon Valley is an area which is outside of San Francisco, where a lot of the big Googles and the Microsofts and so on have evolved. So given that industries tend to develop in clusters, if you're in an African or Latin American country and you want to develop your industry, they plan clusters, and they pick cities and say, let's help this city grow into a petrochemical center or whatever. And this is an example of the country of Trinidad off the coast of Venezuela. It's actually two islands. Trinidad is the big island here, and Tobago, which is shown as an inset map. It's actually located like over here. But anyway, Trinidad and Tobago is the name of the country. It's two islands. So they want their economy to develop and bring in better jobs and so on. So this concept are called, and the term they use is called growth poles. If you're the president or the dictator or whatever, and you say, I want the country to develop more, you could say, well, we're going to give every town $50,000 to bring business in. Well, that kind of dilutes the effort. What you would say instead is, we're going to go into Kingston and develop that as a center of petrochemicals and so forth. If you can read this, they have different examples. One of them is music and entertainment, because remember from the when we talked about the African American contribution to culture and so on in Latin America, we said one of the things was Trinidad was the origin of the music and dance that we know as calypso, with the steel drums and all that. So they're trying to capitalize on that and saying, well, maybe we'll make a entertainment industry here and try and build on that. So this just shows how in different sectors of the country, then you don't want to alienate people. You got to try and spread that out around the country, because, and I think this is the next slide, another term on that slide was uneven economic growth. Uneven economic growth is an issue in every nation, because industry tends to cluster in certain places. So wouldn't it be nice if we all could be Silicon Valley? And every part of the United States is going to develop a Silicon Valley, but it doesn't happen that way. There are winners, there are losers, there are haves, there are have-nots. So we have our Silicon Valleys, but we have our Mississippi Deltas. And we have our the kind of Silicon Valley type areas is around Boston. It was originally called the 128 because that was the name of the beltway around Boston. It was Route 128. A lot of times they're related to universities being there, like MIT and Harvard and so forth. And Massachusetts is the case. Stanford has been a big one in development in Silicon Valley. So it's almost impossible to keep growth and economic development even around the country. Every country has its wealthy states or its wealthy provinces or its wealthy regions, and just different examples of that is a map that was used to show how, in this case, it's not income but income growth, showing that China's gross domestic product varies greatly around the country. In this case, twice as much. Some areas were growing by 13%, some areas were growing by 7%. Here's an example in India, and this legend here with the colors applies to the Indian map, where you have per capita gross domestic product. It's not the same thing as income, but it's certainly related to income. And you have differences of magnitudes of many times, where you have some wealthier parts of India developing, particularly on the west coast, and which have a production that's like more than 10 times that of some other parts, such as this northern state over near Bangladesh and so on. And it's not just developing countries, but back to Italy again. There's been historically, this goes back to, probably the Roman Empire. I bet you could go back and find that northern Italy was more industrial and wealthier than southern industry. And it's still true today that southern Italy, Sicily, the toe and the heel, they're looking at this as a boot, is much less wealthy, much less educated, much higher unemployment than like this section here is the area of Rome, and then northern Italy is Milan and other big cities that have a lot of industry. But anyway, every country has this issue of uneven economic growth. And so, certainly in democracies where people have a say, it's like, well, what are you doing about it? How are we helping Mississippi? How are we helping West Virginia? Well, we're doing the Appalachian Regional Commission to bring money into the area and so forth. In general, something to think about is that transportation improvements can reshape geography. What I mean by that is they can change things around so much that they can, as I say, reshape geography. So some examples in the United States, and we'll see this in a little more detail about the canals, but for example, the Erie Canal in upstate New York, and I'll show you a map of it that connected the Great Lakes to New York City, began a boom all along that canal. That became the boom era of the 1800s, and indeed there was a whole canal era in the United States. Whole canal era in the United States. When the nation got connected, the first intercontinental railroad, not the first railroad, we had railroads even before the Civil War, of course, which was in the 1860s, but one that went from coast to coast. They hammered in what's called the Golden Spike in Utah, where the two sections met. That allowed Atlantic to Pacific and Pacific to Atlantic shipping back and forth. Even things like, this is not intended to be a complete list at all, but even things like iced railroad cars, refrigerated boxcars on trains. Okay, in the old days, they put ice on it, and you could ship meat short distances within states and so on. And then mechanical refrigeration, where you weren't filling with ice, but you had air conditioning units basically on the boxcars that cooled the product, whether it was dairy products or meat or vegetables or whatever. Didn't come about until the 1840s and 50s. Improvements in routes. We'll see a map of the Great Lakes St. Lawrence Seaway, which was completed in 1959. And of course, those are U.S. examples. Worldwide examples, the Suez Canal was constructed in 1869. Suez Canal goes across northern Egypt, where Africa meets Asia, and it allows um, ships coming from India, China, Southeast Asia, back and forth to Europe to cut off the whole distance. I mean, think of the savings of, I don't know how long it would take a ship, maybe a week to go all the way around Africa. So you save the whole week worth of travel. Just as the Panama Canal in 1914 cut off, if you were going to sail when you were in the 1840s, 1848 was it, 1847, you're on the East Coast, you wanted to go into California Gold Rush. There was no railroad, right? It wasn't until 1869. There was no Panama Canal. You got on a ship and you went all the way down the coast of South America, all the way around Tierra del Fuego and so forth, around the southern tip of South America, and then up the west coast. By the way, these are old things, 1869, 1914. It's interesting that both canals now, these are probably you can make a case, these are the two most important canals in the world. Both canals right now are being renovated. In fact, you saw a video on the Panama Canal where they're widening it to allow larger and larger ships. It still won't allow the very largest ships, but it will allow much bigger ones. That'll be a big transportation improvement. And in the Suez Canal, they're also widening that, and they're doing that. But they're literally, they decided to literally construct a second canal, which will be deeper and wider to allow larger boats. Many other examples, the Trans-Siberian Railway, which 1904 connected Moscow and Western Russia to the Pacific Ocean. So that was kind of like the Russian counterpart of our transcontinental railway. And we'll talk about this a little bit more, but the containerized ships, I show you a picture of that. You realize that basically nowadays a lot of shipping is by, you pack the TVs on a truck in China on a, the container, the semi, put it on a ship. Then when it gets off the ship, you just hook it up to a truck again. That's a tremendous innovation that started in the 1950s, and that is still continuing today because we're still evolving larger and larger ships. In the old days, it was a big thing to have 1,000 containers on a ship. Now the biggest ones are holding about 10,000 containers. You read 20,000 TEUs, but a TEU is a 20-foot. A lot of the trucks are actually like 40 feet. So when they say 20,000 short trucks, they really mean like 10,000 semis that you would see on I-70 or somewhere. And another one we already talked about before was the Arctic Sea Route, which I'm saying is kind of starting in right around now in 2012 with just 3 or 4 ships went through, and now more recently it was more like 20 ships have gone through because of the melting ice in the Arctic, assisted by icebreakers when it starts to freeze over. And they still can't go through all winter, so it's only a seasonal route. I just thought this was interesting, talking about refrigerated boxcars and so forth, starting out with ice. There was a whole industry that existed and disappeared, was particularly big in New England. It was called ice harvesting, and it took place in the winters in the 1850s to the 1880s or so. And they literally sawed ice by hand, just like they cut trees down by hand with giant saws, loaded it up, packed it, usually using straw to insulate it, and believe it or not, they shipped it all around the world. So you could cut big blocks of ice in New England, ship it all around the world to India and so forth. If you go to Monticello in Virginia, which is Jefferson's home, you'll see the ice house where they bought ice, kept it. Of course, once you receive it at your house, you had to pack it in ice and so on. So that went on until the arrival of mechanical refrigeration, where they could start making ice and ice cubes locally, so you didn't have to bring it in by great distances anymore. Big transportation improvement was the Erie Canal, as I mentioned. Here is the cursor comes up. Here's New York City. Here's Lake Erie, Lake Ontario. Basically connected these lakes. There were some naturally occurring rivers here, but the point was to dig them deeper, to build locks around the falls and rapids. And basically, this became the boom town within a day's wagon drive, which I don't know, may have been 50 miles or so. That became the boom town at the time because farmers, a lot of New England farmers moved out here, started planting corn and wheat, shipped it by wagon now to the canal to be delivered by boat. And this was one of the reasons. So now New York became the focus of trade and all the Great Lakes, because of course there's 5 lakes out here, not just 2. And this was one of the reasons why New York became one of the big, grew up to be one of the biggest cities. And well, of course, it is still one of the 3 or 4 biggest cities in the world. This is the diagram of how a canal lock works. And as I say, you can go to the web and look for an animation if you want to see something better. But basically, the ship has to go uphill because obviously a river flows downhill. So if the ship is, and a lot of times it's got to get around falls and rapids. So basically, the ship comes in on a certain level, and you have a wall here holding back the water. But anyway, the ship comes in, they close the gate behind it, fill it up like a bathtub. So literally the ship lifts up to the level of the next step. Then they lower that gate or lock, and then the ship flows out. So when you look back at what has happened, the ship used to be at this level, and now it's at this level. And of course it works in reverse. When the ship is going in the other direction, ship comes in here, they let the water out this time, ship lowers, and then when it reaches the same level, they open it here and the ship can go out in that direction. When they built canals, building the canal itself was like half the thing. They also had to build water supplies, so you have things like Lake St. Mary's, which is in western Ohio, north of Dayton, which is the largest, which is totally artificially dug. It's the largest hand-dug lake ever in the world. It was built in the early 1800s, before the Civil War, literally by guys with wheelbarrows, mules, and picks and shovels. It was all done by hand. But the point of it was they needed a constant source of water to provide water for the dam locks, particularly if there were a drought going on. Sometimes you have a river and it dries up to just a little trickle or something. It's like, well, how can you run a canal? So you have to have water reservoirs as a backup to keep the canal functioning. Canal boats were pulled by mules. It was, at the time, it was a wonderful improvement because it was like 10 times cheaper to ship stuff this way. If you envision if that canal boat or canal barge is loaded with goods, and you think about how many mules would it take, or wagon loads perhaps, maybe there'd be 20, 30 wagon loads. So you'd have 40 horses involved in lugging that stuff around. Whereas if you're just talking about pulling the boat, just a couple of mules could do that, could do the work of, let's say that's 100 mule loads of stuff, or it's, it would have taken 40 horses to pull 20 wagon loads to get this same amount of material moved. So that at the time was a wonderful innovation. It didn't last long because that canal era was basically from 1820 to 1860. 1860 is the time of the Civil War. That we had railroads really had just gotten their start about 10 or 20 years ago. So the canal era only lasted about 40 years, and it's amazing how much investment was put into those. And they were immediately replaced by the railroads. And in fact, to add insult to injury, so to speak, a lot of times the railroads ran along the canal paths. So they're literally where we just saw the mules walking, pulling the boats. You had this nice flat land that ran all the way along the Erie Canal, right, for several hundred miles. Just lay the railroad tracks on there. It's already flat. It's already cleared of trees and so forth. So the railroads immediately displaced the canals. But the point of this map is it wasn't just the Erie Canal, which is shown here. But many New England cities wanted canals. Pennsylvania, we had the Chesapeake and Ohio Canal, and actually George Washington was involved in investing in and planning and designing and so forth. And the Ohio was kind of crisscrossed with canals connecting the Ohio River with Lake Erie. Canals going through Chicago to connect Lake Michigan to, called the Chicago Ship Canal, connect Lake Michigan to the Mississippi River here, and so on. So that was quite an ERA of building all these canals in the United States that helped us expand the nation westward. And even those, remember the St. Lawrence Seaway was completed in 1959, but to an extent that's a modern, compared to the 1840s, that's modern times, right? But if you look at this, you can see immediately, well, it's a great thing, but boy, it handles small ships by modern day standards. So you can see how tightly that ship fits into this lock as it's being lifted up to the next level. Little geography trivia for you. I mentioned the Panama Canal. You can be the first person on your block, go home and amaze your parents and friends. But the Atlantic, here's Panama, right? And here, the Atlantic, of course, is on the east. Pacific Ocean is on the west, right? Think of the United States. The Atlantic entrance, because of the way Panama curves around here, and if you look at it in detail, the Atlantic entrance, this is the Atlantic Ocean here, is the Pacific Ocean there, is actually located west, right? That would be on your left, of the Pacific entrance, which would be on the right here, right? So anyway, you can look at the map for a minute, and you'll see what I mean. But anyway, that's an interesting piece of geography trivia for you. And I believe this is the last slide. So a whole theme through this has been that transportation improvements, such as, let's say, interstate highway, canal, railroad, refrigerated boxcar, whatever it is, and energy costs can greatly affect trade. Most international trade goes by ship. It's slow but cheap. Water shipping is like 1/10 the cost of land shipping because the water is supporting all the weight. You just have to keep the thing moving. But it takes longer. Sometimes it's your only choice. You can't go from China to California by land, so it's really your only choice. Then, of course, and we have truck and rail. Rail is much cheaper than truck, but it can't get everywhere. So the rail can bring, and a lot of times, of course, they take these containers from the container ship you see below, put them on rail first, maybe ship them from Los Angeles to New York, then take them off on a truck and ship them to, Harrisburg, Pennsylvania, or wherever it's going. And we even do some shipping by air. Air freight is very fast, very expensive. If you're shipping a laptop by FedEx, well, it's back to the example of the watch. If you're shipping a small item that's worth $1,500, then it's worthwhile shipping it by air. One of the few products that are shipped in volume by air turns out to be things like fresh flowers. A lot of the flowers, if you go to a floral shop and send a bouquet for funeral or wedding or whatever is going on, those fresh cut flowers, a lot of them come from Colombia in South America, and they're shipped on planes because now you're dealing with a freshness issue. You can't put those flowers on a ship and expect them to get to New York or wherever they're going in very good condition. So, well, this will wrap up, at least for what we're talking about in economic geography for today.